Periodic motion is any motion that repeats itself over and over again along the same path. Most of the roller coasters at our amusement parks exhibit periodic motion. You also see periodic motion with the hands on a mechanical clock. The hour hand, the second hand, and the minute hand rotates around at different amounts of time, different rotational speeds. It takes the second hand 60 seconds to go all the way around one complete cycle. So the period of the second hand is 60 seconds. It doesn't matter if we start at the 15-minute mark and go all the way around back to the 15-minute mark, or we start at the 12 o'clock mark and go all the way around. It takes 60 seconds to get from one position back to that original position. The minute hand takes 60 minutes or 1 hour to go all the way around once, and the hour hand takes 12 hours to go all the way around once. Those amounts of time are known as the period. Pendulums also exhibit periodic motion. The period is the amount of time it takes to make one complete vibration or one complete cycle. So if we were to time this to go over and back, we would get the period of this pendulum. We could also time it as it swung from straight down over to a maximum, back to the other maximum, and then back to that original position. It takes the same amount of time to go over and back in that path as it does to go from here to there. That's the period. Waves also exhibit periodic motion. There are 6 basic characteristics of all waves. All waves have a velocity, a frequency, an amplitude, a wavelength, a period, and a phase. We can model wave motion with this long piece of fabric. I can move my arm up and down, and you can see what would amount to a transverse wave. The transverse wave is a wave in which the displacement of the particles of the medium is perpendicular to the direction the wave is traveling. The frequency of the wave is related to how rapidly I'm going up and down. So if I do this very rapidly, that's a high frequency. But if I go less rapidly, that's a low frequency. We can actually measure the frequency by counting how many complete back and forths I make divided by how much seconds. So the frequency of a wave is its number of vibrations per unit time. When that unit of time is the second, we call the frequency unit the hertz. 60 hertz means 60 cycles per second. A middle C tuning fork of 256 hertz vibrates back and forth 256 times every second. The period is the amount of time it takes to make one cycle. So if you made 2 cycles in 1 second, then it takes 1 second to make 2 cycles, or half a second for each cycle. Frequency and period are inverses. The period is cycles, or frequency is cycles per second, period seconds per cycle. So if I wanted to get the period of this wave, how much time to do that, to do that, to do that, to do that, to do that? That would be one complete cycle. The amplitude of a wave is the maximum distance between the equilibrium or midpoint up to a high point or down to a low point. If it's transverse, where we would have crests and troughs, or if it's longitudinal, it would be the distance to a maximum or minimum in either direction. So amplitude would be the distance from my midpoint to the peak or the midpoint to the low. It is not the top to bottom distance of the wave. It's half of that. Amplitude is unrelated to frequency. I can have a low frequency with a large amplitude, or I can have a high frequency with a large amplitude. Amplitude and frequency aren't related. Wavelength relates to how spread out the wave is. It's the distance of one complete cycle, or it's the distance from one point to the next point on the wave that's in phase with it. when we're watching this, wavelength is related to how spread out those crests are. So I could have a short wavelength where they're really close together, or I could have a longer wavelength where they're spread out. So wavelength is a unit of distance, and we usually measure it in meters or feet or inches or centimeters, and we use the Greek letter lambda to represent wavelength. Another characteristic is the speed of the wave. The speed of the wave is not related to the frequency. So don't think of, I'm doing this fast, so that's a high speed. Speed of the wave is distance divided by time. If my wave starts here, how much time did it take to end up over here? That distance divided by the time. So I can have a high frequency with a slow speed, or I can have a high frequency with a fast speed. So frequency and speed are not related. The speed of a wave is totally determined by the properties of the medium. How I move my arm back and forth in no way affects the speed of the wave. The speed of the wave is determined by how quickly I walk or run from this location to the other, which is independent of this motion. The last character, speed can also be determined not only by taking total distance over total time, but taking a distance of one wavelength divided by the time of one period. So period is the amount of time to make one complete cycle. Wavelength is the distance of one complete cycle. So that distance over time, wavelength over period, will also give us the wave speed. But since period and frequency are reciprocals, dividing by the period is the same thing as multiplying by the frequency. So for a wave, velocity equals wavelength over period, or wavelength times frequency. Normally, we write that equation as velocity equals frequency times wavelength. So there are two ways to get the speed of the wave: frequency times wavelength, or distance traveled divided by the time to travel. The last characteristic is the phase of the wave. Phase has to do with the position and motion of the particles of the medium. In particular, we care about the phase when we're starting our wave. So when I start my wave, I could start in the middle and go on the way up. I could start at the middle and go down. I could start at a high point, or I could start at a low point. All of those would be different phases. Think of creating waves of water. You can start the wave by pushing down on the water to splash, but you could also be underneath the water and lift up to make the wave. Those would be different phases. So the velocity of the wave, the frequency, the period, the wavelength, the phase, and the amplitude are the 6 wave characteristics. We also have 4 wave properties. Properties are things that waves do. They reflect, they refract, they diffract, and they interfere. All waves exhibit those 4 properties. Reflection of the wave is when the wave is traveling through one medium, gets to the boundary of another medium, but turns back and stays in the first medium. We don't want to say the wave bounces off. It turns back, it returns for reflection. Refraction is the change of direction of a wave as it passes obliquely from one medium into another of different transmission speed. When a wave enters a new medium, coming in at an angle obliquely, not head-on, and it changes speed, it will change direction. The direction that it changes is determined by, does it speed up or slow down in the new medium, and by how much. The third property, diffraction, is the spreading of a wave around a barrier or through an opening. When water waves go through a small opening, they'll spread back out after going through there. when sound enters a doorway, it spreads out into the room. That's diffraction. And then the last property is interference. This is the result of the superposition of two or more waves in the same place at the same time. Effectively, their amplitudes add together. The waves don't really interfere with each other. Interference is what happens to the medium. The medium feels the effects of both waves. In Physics 110, you should have discussed these characteristics and properties as they relate to sound waves. In Physics 112, we look at how they relate to light waves. We'll look at how light reflects, and here we study mirrors, flat and curved. We look at how light refracts, and we study lenses. We look at how light diffracts and causes interference patterns. So diffraction and interference typically go together. The chapters in your text and the slideshow notes posted in Canvas will be helpful to you as you explore the characteristics and properties of light waves.